Waves at interfaces. Well, what's an interface? Well, an interface is the boundary between two different materials or substances. So when you have a boundary between two materials of different properties or two substances, different properties, then we have an interface. For example, the point between water and air, that boundary is an interface. Or between glass and air, that's an interface. I know in secondary school you're familiar with water here, glass here, under optics. That boundary between these two different medium or media rather is an interface. And likewise in physics, an interface could also be referred to as the boundary between two faces of the same material. So when you have solid and liquid, the interface, or gas and liquid, the boundary is an interface. For example, water and liquid and iced water. That's a solid form of water. The interface between water and ice is an interface. There is a change in certain property, or you move from liquid form of water to a solid form, which is ice. So those can be referred to as. So when a propagating wave encounters a boundary, the behavior of such wave depends on several factors, which have been classified into two. The first is the properties of the wave, and the second group the properties of the materials at either side of the interface, that is, the property of the two different media. So for the properties of the wave, let's look at it. We have angle of incidence of the wave and also the wavelength of the wave. Let's look at this figure to get understanding. The angle of incidence, you could see the different wave fronts at different angle of incidences. You could see how they behave. Though the same pair of media, you could see their behavior. And recall the expression you know, which is called the Snell's law, where it is said that sine I over sine R is the ratio of the sine of angle of incidence to the sine of angle of refraction is equal to the ratio of the refractive index of the medium in which refraction took place to the refractive index of the medium where incidence, where wave is incident on the boundary. So that's what, so we'll see that. So no matter what, if it's kept constant, maybe just glass and water, or glass and air, or air and water, as I changes, then the behavior here changes. And to get to a point that this will become maximum, or it become zero, depending on the angle of incidence. Then number two is the wavelength of the wave. So we look at the wavelength of the wave can also affect the behavior. Remember that wavelength is determinant of the energy of the wave. So wavelength affects it. And note that no matter the medium, frequency of a wave remains constant, does not change. So, but because of the refractive index, changing refractive index, Then the wavelength of the wave will also affect the speed with which the wave propagates in the medium, though the frequency of the wave remains constant, but the speed will be affected as the wavelength of the wave determines the speed in such a medium. Then the second group is the property of the materials on the other side of the interface, that is the two media, and that's the density of the material, the elasticity of the material, and the refractive index of the material generally. And this gives us an idea of what happens at interfaces. Here, I just use this to depict that. If you see this figure, the figure there, the arrow, the biggest blue arrow there, is represent the component of the incident wave. This represents that of the reflected wave, and T shows that of the transmitted wave. So the wave propagating in medium 1 encounters a boundary, and I didn't put a line, but you will see I intentionally faded it. You will see that the changes in the property of the medium. At this point, that you see it is lighter, then we have a white, then we have blue, just to illustrate the change in the medium. And this is what happens. So wave encountering an interface would exhibit either reflection, that the wave would be reflected, totally reflected, or totally refracted, which we now call transmitted, or certain percentage components will be reflected and some transmitted, depending on, again, several properties that we have earlier considered.